Welcome back, everyone. So far, we've built a strong foundation, understanding classes, constructors, properties, and object-oriented design in C#. Now, it's time to take the next step. We'll explore how to make our user-defined types behave like built-in types by using operator overloading. We'll also look into how C# allows us to customize how objects are printed or compared through overriding toString and other inherited methods. The goal is simple: to make your classes more natural, more intuitive, and more professional to work with. Today's lecture will focus on how to extend C# classes beyond basic behavior so they can support operators like plus, minus, etc., and integrate better into the language's natural syntax. We're stepping closer to building truly complete classes, not just basic containers of data. Let's dive in. Here's our journey today. Introduction to operator overloading syntax and examples for binary and unary operators. Customizing object output with toString. The focus is on designing types that behave seamlessly and intuitively inside a C# program. What is operator overloading? It's the ability to redefine the behavior of operators like plus, minus, check if equal when they are applied to your own classes. The key purpose: to make working with your classes feel natural, like working with numbers or strings. Without operator overloading, combining two objects would require awkward method calls. With it, we can simply write object1 plus object2, much cleaner and more readable. Important rules when overloading operators. Use the keyword operator followed by the operator you want to redefine. The method must be public and static. For binary operators, like plus or star, the method takes two parameters, a left-hand side and a right-hand side. This structure enforces clarity and uniform behavior for operators across all user-defined types. Not all operators can be overloaded. Allowed operators: most arithmetic operators such as addition and subtraction, comparison operators like equality and less than, and logical operators including and or. Not allowed operators: some language-specific constructs such as assignment, logical and logical or conditional, new, and others. C# enforces this distinction to protect language integrity and prevent confusing behavior where it is inappropriate. Remember these limitations. You cannot overload operators for built-in types like integer or double. Some overloading has automatic implications. Overloading addition also affects addition assignment. Overloading bitwise and bitwise OR affects logical and logical OR. These restrictions ensure that overloaded operators still behave predictably for developers reading your code. Special operators allow you to control overflow behavior in arithmetic operations. The checked operator throws an exception if overflow happens. The unchecked operator allows overflow silently. For example, adding two huge integers can crash with checked, but wrap around silently with unchecked. The new operator, known as the default operator, behaves like the checked operator, but does not require explicit declaration. It automatically checks for overflow and can help maintain code safety without additional overhead. This concept teaches defensive programming, anticipating and controlling dangerous situations. More special operators. Type of: gets the type metadata at runtime. As operator, tries to cast safely, returns null if it fails instead of crashing. Is operator, checks if an object is a specific type. These tools are critical for type safety and dynamic behavior when working with unknown objects at runtime. Here's a classic binary operator example, adding two vectors. We overload plus so we can write vector result equal vector 1 plus vector 2. Behind the scenes, the overloaded plus method adds the x and y components separately. This reflects the principle of natural interaction. Your objects behave like mathematical concepts without complicated syntax. Unary operators operate on one operand only. Here we overload the unary minus operator to negate both parts of a complex number. This shows that even single object operations can be customized to make your types smarter and more natural to work with. In summary, operator overloading increases expressiveness. It must be public and static. Some operators cannot be overloaded. Special operators provide control over runtime behaviors. Always overload operators carefully. Make your classes behave naturally, not surprisingly. Operator overloading is not about showing off. It's about making your classes more usable, allowing client code to combine, compare, or manipulate objects as easily as primitive types. When done right, operator overloading makes your code elegant and human-readable. Another important rule: overloading equals requires also overloading not equals. Overloading less than requires also overloading greater than. This is called pairwise overloading. It ensures that opposites like equal versus not equal always stay logically consistent in your objects. Standard syntax for overloading operators: unary format, public static result type operator operation, operand input. Binary format, public static result type operator operation, left input left, right input right. The enforced syntax for operator overloading is key to maintaining a standard approach. This standardization makes overloaded operators behave in a predictable way and simplifies the process of identifying and fixing issues. Example from the book class: adding 2 books creates a new book with a combined title, combined number of pages, higher price plus an extra charge. This shows that overloading can involve smart business logic, not just raw math. Inside the overloaded plus operator, we create a new book object that merges attributes from 2 originals as in the previous slide. This principle, creating new combined objects instead of mutating existing ones, is crucial for writing safe, predictable programs. Here we see a full program using overloaded operators. 2 books are created. They are added with plus. The result is a new book with merged attributes. Operator overloading allows powerful yet intuitive object interactions in C#. Unary operator overloading lets you redefine how a single object behaves with an operation like negation. Example: negating a book's price. This emphasizes the programming principle of precision control over object behaviors. Next, we'll discuss a key feature that allows objects to describe themselves: overriding the toString method. Although every C# class comes with a built-in toString method, its default output lacks detail. By overriding it, you essentially teach your objects how to present their important information as a string, which is crucial for understanding their state during debugging, recording their activity in logs, and displaying them effectively in user interfaces. Final key points from today: operator overloading enhances class usability and expressiveness. Binary operators must be paired correctly. toString improves object readability. Every design decision you make, overloading an operator or customizing toString, should serve the larger goal: making your code more natural, reliable, and professional.